I'm Anil Kumar sharing with you a question from my student Gurmeen. Gurmeen, thanks a lot for sharing this question, and I hope many of our viewers will benefit from its solution. We'll actually try to understand how to factor polynomials. We've taken two very special cases where we are going to consider difference of squares and difference of cubes, right? Okay. Now let's begin with the very first one, which is we have four terms here. So what we can do is that we can combine the three, a trinomial, and then as you can see here, minus 4y squared. So that's a perfect square, right? 2y whole square. So that gives you an idea that we could do difference of squares here. So we are going to do difference of squares to factor. Now, how could we get a perfect square by this trinomial? Well, let's rewrite and try to understand. So what we have here is 9x squared plus 6x plus 1. And this could be written as, 2y whole square. So this is a perfect square, clear. Now 9x could be written as 3x whole square. And the center term 6 is 2 times 1. Let me write 1 here, times 3x. And now we could write plus 1 and minus 2y whole square. As you can clearly see, these three terms form a perfect square, right? So I could now write this as 3x plus 1 whole square, and here we have minus 2y whole square. So the difference of squares can work, right? A square minus b square we can now use. So at this stage, I use this particular formula, that is a plus b whole square is a square plus 2ab plus b square. And now I'm going to use the third very important formula, which is a square minus b square equals to a plus b times a minus b. Difference of squares is product of their sum and difference, right? So for me, a is going to be this part. So this is a for us and that is b for us, correct? So a square minus b square is a plus b times a minus b. So let's add these terms. So we get 3x plus 1 plus 2y times 3x plus 1 minus 2y. Got it? Now you can just rearrange 3x plus 2y plus 1 times 3x minus 2y plus 1. So that becomes the factored form for the given polynomial. Perfect. So that is how you're going to do it. Now let's do the second one. Well, I thought this is difference of cubes, but actually x plus y is a common factor, so it reduces to a simpler question. As far as the number goes, 27 and 12, 3 is a common factor. So what we can do here is that we can take 3 times x plus y as a common factor, right? So as soon as you take 3 common, first term, 27 divided by 3 is 9. And x plus y whole cube divided by x plus y gives me x plus y whole square minus 12 divided by 3 is 4, and we have already taken x plus y common. Correct. Now this expression can be written as 3 times x plus y, and again you see this is a square, 3 square, right? So we could write this as 3 square. So let me write this as 3x plus y whole square minus 2 square. So it is kind of difference of squares again, right? So we could now factor it. I mean, this was a step only introduced in between, not really required, to make things clear. So now I could use the same difference of squares formula here to factor, which is add these two and take difference of these two. So what we get here is 3 times x plus y plus 2, right, times 3 times x plus y minus 2. So that is how we'll factor, right? So we get 3 times x plus y. Here, let's open the bracket. So we get 3x plus 3y plus 2 times 3x plus 3y minus 2. Got it? So that becomes the factor for the given expression. So both of these polynomials were factored using difference of squares mainly. I hope that helps. Feel free to write your comment and share your views. Thanks for watching and all the best.